Dear God, what's going on in space? We'll let you know. Lots to cover today. We'll even talk some extra information about coronal holes that we don't normally talk about. Some interesting coverage for you coming today at the Daily Space Weather. This is the past 24 hours from SDO in ionized helium 304 angstroms, the classic ionized helium wavelength. Some major CMEs, coronal mass ejections, happened in the past 24 hours. And an over-forecasting by pretty much everybody, including me and NOAA. Here's a northern region. There's actually a solar polar vortex going on right now. You can see some plasma encircling the north heliographic polar area. Here's a close-up of that. And you can expect to see lots more crown prominences, like that prominence over above and to the right of the Earth scale there. Expect to see lots more of those as we get closer and closer to solar maximum. Again, there was a major coronal mass ejection. We'll let you know if it's earthly directed later in the video. And we'll show you some great detailed imagery of that as well. Here is the southern polar region. Some prominentiary filament activity there. In the southwest, here's the southeast. And the likelihood of coronal mass ejections remains nearly 100%, also significant possibility of major solar flares. Great view of that huge filament there. And here is the northeastern quadrant. And you can see some activity from that sunspot there. We've got a number of magnetically complex sunspot groups. And here's a brief close-up of some more plasma filaments here rising over the northeastern limb. How about if we take a brief look at sunspots? Just kidding, folks. I wasn't asking. This is a dictatorship. And let us know in the comments if your local bureaucracy is a dictatorship. That is yesterday plus today on the SDO intensity gram. Not a lot of changes happening there. Most of those groups quite stable. There is your colorized magnetogram for yesterday plus today. I don't think we've got any new named sunspot groups. We'll look more in depth here in a minute. First, take a moment to visit the links below the channel in the description. If you haven't seen them, check them out. Today's featured product is our bestseller. It's a public service message brought to you at massive personal risk and expense by Smash staff and I. Do not pole vault the caldera. After all, that could be unhealthful. Now, this great design not only features the public service message of do not pole vault the caldera, it also features our homepage, smashomash.com. And by the way, you can find a link to the Smasho merch at smashomash.com. You can also find the Redbubble shop linked below this video in the description. You'll also find the YouTube URL. And if you're viewing the videos on BitChute or any place besides on YouTube, get real. Go subscribe over on YouTube. You're missing like 98% of the content. If you're going through hell, keep going. And if you're going on a volcanic vacation, leave that vault pole at home. Don't pole vault the caldera. We need the views on YouTube. So you can help out the channel not only by picking up the merch there, but telling your friends and foes about the products by perhaps wearing a lovely t-shirt or perhaps an A-line dress with that logo. And let's move to the realm of volcanism. Yes, volcanism. We want to know what volcanoes are erupting, so here's the list. Mount Mayon in the Philippines is erupting, producing an unknown ash plume. Please do not fly your hang glider or home-built kit helicopter over Mount Mayans caldera. Santiaguito, no recent volcanic ash observed from Santiaguito in Guatemala. However, Fuego exploding flight level 170. That's a 17,000-foot ash plume over Guatemala. Nevado del Ruiz exploding in Colombia, flight level 230. Revenador exploding in Ecuador, flight level 140. It's a 14,000-foot ash plume. Headed down to Peru, we've got 2 suspects down there. Sabancaya exploding, as well as Ubinas. Sabancaya producing a 23,000-foot ash plume. Ubinas producing a 21,000-foot ash plume. That's a flight level 210. And let's look at seismicity. There are the past 90 days, and the past 2 days have been very calm here. So only one quake of a 5 or larger magnitude. That occurred south of Tonga at 13:52 Universal Time yesterday afternoon. Besides that, not a lot going on, although some quakes there looking like they occurred around the San Andreas Fault. So I see some quakes there at southern California, also around the western Pacific Rim, but a very calm 24 hours there in terms of earthquakes. Just keep in mind, folks, any earthquake can be a foreshock. And let's get back to space, which is where it's at. Here we've put together 171 plus 211 angstroms. And that is one of our favorite composites. And let us know what your favorite wavelength is. Is it 335? Is it maybe 1600 angstroms, which shows ionized carbon? Is it 304 angstroms showing ionized helium? Maybe 171 angstroms showing ionized iron? Once again, that's the last 24 hours from SDO. And let's take a look at some stats. The 10.7 centimeter radial flux is now at 161 solar flux units. And if you're new to the channel, you may not be aware that the 10.7 centimeter radial flux is the most proportional data set to sunspot number, and there it is depicted in a one-year graph by the black line there. You can see the sunspot number has recently crossed over the radial flux. Sunspot number is actually at 189 now, so it's actually up here. This will be updated soon here at Solon.info, the source of this graph. The pink line there is the 30-day sunspot number average. And if you look at the black and red lines, you can see how proportional they indeed are. The radial flux and the sunspot number, the two most pertinent variables to solar activity. So Space Weather Enthusiast dashboard here, back to not predicting any geomagnetic storms or geomagnetic unrest. Yesterday's coronal mass ejection impact was a dud. Barely even noticeable there. It mainly just moved past. It was probably a miss to the south and east. It was a little bit off to the east. And again, there was barely a signal there. We'll get to it here in a moment. Before we do that, here are the last 4 hours of Earth's magnetic moment from space. It's our Geospace Magnetosphere movie. And we are back to geomagnetically calm conditions following just a couple brief periods of geomagnetic unrest. Never even really got to what you'd call a geomagnetic storm yesterday. There may have been some aurora photographed, and if you did notice any, hit us up on Instagram or on Twitter, links below the video to those accounts as well. So that's the past 4 hours, Earth's magnetic moment from space there, depicted in magnetohydrodynamic pressure. Things are quite homogeneous here at the moment. Here are Earth's ground-level magnetic perturbations. Earth's magnetic moment from the ground, depicted in magnetic flux density nanotesla, are the units of magnetic flux density. It's been a calm past 4 hours in terms of earthly ground-based magnetism. Planetary K-index only at 1.33. KP 1.33 is the average of global geomagnetism at the moment. And looking at the real-time solar wind here, again, barely a signal showed up yesterday. I suspect that this may be the CME right in here, as we do see a change in the plasma temperature. The phi angle shifts. That is the spin moment of the incoming plasma. And you can also see the BT-BZ. The BT goes up a little bit. The BT goes up a little bit. The BZ shifts a little bit. But yeah, very weak CME, quote, impact, end quote. It was more of a field exposure than it was a particle impact. Current conditions are about 5 protons per cubic centimeter for the solar wind density, solar wind speed here. Quite unremarkable at 400 kilometers per second. Here are the GOES magnetometers, and we did have some spiky moments there. The ionosphere did puff up a little bit. So you can see both the GOES 16 and the GOES 18 there, as evidenced by those arc jet moments, needed to do some maneuvering to maintain their geosynchronous near equatorial orbits. That's 3 days of GOES 16 and GOES 18 magnetometer readings. And let's talk about the heliospheric current sheet. So we show it, this is the past 4 days, we show it regularly on the channel. And we do that because that is an important feature of the overall heliosphere, right? So the heliospheric current sheet is polarized. The plasma that comes out of the sun there is oriented to one magnetic field or the other. This depicts red for south and green for north. And just keep in mind that the heliospheric current sheet is wavy. And it does change. And it is a 3-dimensional thing. I mean, we're only showing it from a 2-dimensional plane here. But the heliospheric current sheet, it does vary throughout the solar cycle. And it's much more homogeneous and less bumpy and less wavy and less dense at solar minimum than it is at solar maximum. So this is depicting sector boundary crossings here in green. So these are the areas where there is a sector boundary crossing. Here you'd be moving from the South Pole to the North Pole current sheet as the sun rotates in this fashion. So anyway, this is the depiction of the top view ecliptic plane field plot. This shows the polarity of the plasma in the current sheet. And Earth has just recently moved into the South Pole current sheet. So it's just made that move, or it's just about to. Probably already did it, as this data is 1 hour and 12 minutes old. So South Pole current sheet there, Earth just crossing a sector boundary crossing into the southern current sheet. Moving along to the line of sight field plot. Here the sun's B field is depicted in blue. And that is where the sector boundary crossing is going to be, where you see the B field there crossing over. South Pole current sheet headed this way. There the solar B field is. That's the solar B field there in blue. North polar field in green, south polar field in red, and of course the grayscale depicts the magnetism on the photosphere level. That is what you would call the surface of the sun, the photosphere. Above that you've got the chromosphere, and above that you've got the corona, which is what we're mostly showing on these videos. And let's move to coronal holes. So here's the coronal hole situation. We've got South Pole oriented coronal holes rotating in here. We've got a well-defined North and South Pole oriented coronal hole. So let's take a look at those in 211 angstroms. So there's 171 angstroms plus 211, and here we've subtracted the 171. So here's a great example of opposite polarity coronal holes here. Here's north. This is north. This one here is south. And the sector boundary crossing is something like this. That's a 24-hour SDO video. 211 angstroms is the wavelength. It's ionized iron. And here's a really interesting feature that you may not be aware of. Did you know that coronal holes might actually not be the source of the high-speed solar winds? Here's a paper about it. Coronal holes in low latitude may not be the origin of streams and of 27-day recurrent geomagnetic storms. So this is one of those many things, folks, where it could be a lot more complicated than it seems. And I don't want to comment on this too much, as I just read the paper yesterday. It's still sinking in. I may have to skim back over it again. But shout out to Eugene the Philosopher, another YouTube content creator. Make sure you go check out his channel if you haven't. And I'll just briefly allow this to scroll here. So it is possible that the coronal holes are not actually the source of high-speed solar winds, but they are associated. So now this is easier to sort of figure out at times of solar minimum than at times of solar maximum because of the chaos that happens as the solar polar fields reverse. However, at solar minimum especially, there is some indication that latitude is just as important as the actual exposure to coronal holes. So the Ulysses spacecraft helped with this, as it showed us that there are certain latitudes associated with certain average solar wind speeds. Now again, keep in mind at solar minimum it's a lot less complex than at solar maximum, and there are all kinds of advantages to studying this stuff at solar minimum. Of course, it has to do with the three-dimensionality of that heliospheric current sheet and the B field motions and all of the different streamer filaments and so forth. So, but it is possible that the streamers on the edges of the coronal hole streams are really the feature. So, interestingly enough, and by the way, make sure you subscribe to Eugene the Philosopher if you haven't. Eugene the Philosopher, one of the top contributors to the channel. If you've never seen the videos, perhaps check out this one, Science is Not a Worldview. We're trying to get Eugene to 1,000 subscribers here. He's only got to get 578 more. So please go subscribe to Eugene the Philosopher. Some great information there. There's even one about more flares at the limb. This is a paper that we actually sort of contributed to a little bit there. There is an acknowledgement in that paper. Anyway, but science is not a worldview. If you think you're the science, you might be a cult leader. Eugene the Philosopher. Make sure you go subscribe to his channel. It is fantastic. Now, one of the things that I want to share also here, continuing to talk about coronal holes, is spaceweather.com. So this is actually where I first started following space weather back in the early 2000s. And so maybe check out this site. It's always got some interesting information on it there. Spaceweather.com. That was the original spot. And the reason I'm bringing it up is because one of the things that I've noticed is that when we cover space, when we look at spaceweather.com, when there are coronal holes, they often draw in the coronal holes in this fashion. They're the source of high-speed streams, and they show arrows coming out of the edges of the coronal holes. And that could be because the walls of the coronal holes are really the source of the high-speed stream, not the coronal hole itself. In other words, this thing does not act like a fire hose. It's a little bit more complex than that. It's probably got to do with some sort of field and filamentary interactions. But anyway, I just wanted to clarify that because, folks, the physics matter when it comes to understanding how things actually work. The physics matter. This is why we don't say that solar flares cause coronal mass ejections, because cause and effect are what physics is all about. So let's get to sunspots next. So here is the Integrated Space Weather Analysis Center. And again, no new sunspots here. These groups have been quite stable. The newest one is 3366. 3366 is the newest sunspot. The next one will be 3367. There may be an active region rising up here in the northeast. So that is sort of the most likely candidate for a new sunspot. And let's take a look at a 24-hour video here. That should back up what I've just said. And I stand corrected. So there is one new Beta Gamma class sunspot group that formed right here. This is a 24-hour SDO continuum video, and right there is a new sunspot. So that'll be 3367. And if I've missed any, feel free to let us know in the comments. On this channel, we like being wrong. We don't try to gaslight our viewers when we are incorrect. We just get ahead of it, move on, and not shartlight and look like fools as a result of that. Next, we'll move to energetic particles and solar flares. We ain't got no energetic particles. It's been a long, long time since a solar energetic particle event. I think we are long overdue, considering that we're only like probably less than a year from solar maximum. And here's the flare profile over the past 24 hours. There has been one M-class flare. Besides that, only C-class intensifications and a slight dip in the background flux. I'll say the background flux is about a C1 right now, maybe a C1.3. C1.3 is the background flux. And let's take a look at some of our favorite flare wavelengths. So here we've put together 171 plus 131 angstroms. Another 24-hour SDO video. Let's swap out 94 for 171. There's 131 plus 94 angstroms. And there is 94 angstroms by itself. Again, there are a number of magnetically complex sunspot groups. The likelihood of large solar flares remains. And next we'll talk about CMEs and filaments and so forth. First, let's take a look at a star chart. So this is what's going on overhead at Lehigh Valley, Pennsylvania right now. Actually, that is right now. So you've got Mercury trailing the sun there. If you've got a low horizon and clear skies, you might see Mercury just after sunset. Depends on how close to Earth's equator you are, as it does affect how quickly it gets dark. And if you're up looking at the post-sunset sky, you might actually see Venus and Mars. A little more likely to see Venus and Mars there. Two very bright objects quite close together. Mars and Regulus very close together as well. They're right near the ecliptic. And here comes your solar system forecast. This is where things are today. We'll move it ahead 1 week. Here's where things will be on the 15th as we are approaching another new moon for the month of July. It will be a crescent waning moon by the 15th. And take a look at some CMEs next. Yeah, CMEs. We cover them here at the Smash News Network, least busted name in news. And by the way, congratulations on realizing that the channel exists. So yesterday, right as our video was premiering, there was a sweet CME erupting. It's actually sort of a double pulse. You can also see one out of the northeastern limb there. So a bunch of material ejected from the west. A bunch of material also ejected from the northeast. We'll show more in-depth imagery of that here in a minute. First, today's frames. There's an additional 22 frames from today, July 8th. So let's take a look at Stereo A, because Stereo A's got some fresh images. But first, Soho Lasco C2 and C3. And here's a diagram of the locations of things like Bepi-Colombo, Stereo A and B, the Solar Orbiter, and the Parker Solar Probe. Feel free to pause the video in this frame if you're not familiar with where those things are. Here's Stereo A on the left, and Soho Lasco C3 on the right. So let's bring this back here. Here's a great CME. Massive CME there. It really is two events. And a bunch of missing data there does not help. There's about 6 hours of missing data there, but great view of that CME coronal mass ejection from Stereo A. Starting out around midday yesterday. So it doesn't look like it is earthly directed. I don't see any indication that there are earthly directed components there in the imagery. That one out of the northeast looks like it is a separate event. But let's just make sure by looking at our custom coronagraphs. So here's another 24-hour video for you. That is SDO 193 angstroms, Soho Lasco C2 and C3 for 24 hours. No halo from those CMEs. Here's a little closer view. Quite a chaotic coronal mass ejection. There was a huge backflow actually that happened there. A bunch of that plasma decided to give up the magnetic field force lines there and succumb to gravity, collapsing back toward the sun. Great example of a backflow. Here you'll be able to see that material headed back down toward the chromosphere in the upper right. Actually, it's better viewed in this. There you go. You can see this right up here, a huge backflow happening. And as far as where that CME came from, it came from this active region that's set up here in the northwest, it looks like, as we don't really see a major plasma motion happening there associated with that coronal mass ejection. Here's just 193 angstroms. Yeah, so that is not earthly directed. In fact, it's somewhat on the far side of the sun. Moving right along here, it's time to look at filaments. And there are still quite a bit. So, to that end, here are the data from the ground-based National Solar Observatory here at El Teide, Spain. And some of the Alex Lifeson filament are still in place. This one here could get a name. We've been naming filaments after living people. And if you want to do that yourself, well, do it over on Twitter. Follow the hashtag #NameThatFilament. And who do you think will win the cage match? I want to know. And you may get other information that you won't see anyplace else besides on Twitter. And if you want to get even more information than that, why not join us over at the Smash Team site at smashomash.com/SmashTeam. That's the official subscription services site of the channel. So if you want additional content, we have a paywall. Now we have a Patreon also, so you can donate that way. Oh, and check it out. Smash staff put up the Spotify link. So there's original music there on Spotify as well as on Amazon Music, YouTube Music, etc. You can also find the Hemp Lucid, the Amazon shop, and more on the homepage. This is smashomash.com/SmashTeam. Because, well, we needed additional capabilities, so we launched back in October of 2021. Not the optimal time to launch a subscription services site, obviously, with the state of the scamdemic economy and so on. So, but in any case, hey, there you go. Smashomash.com/SmashTeam. People wanted additional content, so we're giving it to them, especially for the gold and silver Smash Team levels. There's also a bronze level. You'll get email alerts to see videos just like this one. So to everybody who's not receiving the notifications that videos are going up from the Smash News Network, Least Busted Name and News, just sign up for email alerts at the Smash Team site, and you'll get email notifications conveniently sent to your email inbox. Seems like a pretty simple solution to the problem of complaining about YouTube not sending notifications. You can also find links to the Hemp Lucid shop there, so check that out if you haven't. Links on the homepage at smashomash.com, as well as below this video to the Hemp Lucid paid affiliate/sponsor link. That is the paid promotion you see in this video, one of them at least. There's also the Amazon shop. Check out the products there. Help out the channel and help out yourself with some of our Amazon picks. Before we do our bonus feature segment, we'll look at the last couple of hours here from the GOES 18 SUVI. A little bit of additional CME activity happening right up here in the northwest, and a lot of prominence is there all around the rim. And here comes our bonus feature segment. Satellite charging hazards are non-existent. It is smooth sailing for satellites. The GOES electron flux is surprisingly high because the CME impact was surprisingly weak. So there you go. That is the past 3 days. We expected that to be much lower because we expected the CME impact to be much more significant. However, it wasn't. There still was a dip. It was sort of a minor interaction. That's a 1-year graph of the relativistic electrons, the greater than 2 mega electron volt electron fluence. There's the forecast model. And of course, we're going to see levels right about here where the forecast is. We were expecting it to be quite a bit lower there. That did not materialize. That electron flux is measured at the F layer of the ionosphere. It's located at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with distances, chemical concentrations, electromagnetic penetration through atmospheric layers, etc. Here is the vibrational frequency of the F layer, the bridge between Earth and space. And you will see some low-frequency anomalies happening here as the ionosphere did puff up a little bit in response to that CME mostly brushing past. So here's the latest image. That's the anomaly in megahertz from the 30-day median. This data is courtesy of Australian Government Bureau of Meteorology. And you can see quite a bit of red on the map there. That is the ionosphere slowing down a little bit there as material puffs up. That is a common feature of coronal mass ejections and high-speed wind streams. So anyway, nothing too major going on there in the ionosphere. Here is the latest image, 1245 universal time ionogram, and there's 1245 universal time anomalygram. We also like to show the total electron content forecast. It helps with GPS errors, GPS error prediction. It also tells us things about space weather and possibly even seismicity. So here's a total electron content forecast, and we are seeing some little bands of electrons there out of place. This is depicting the free electrons from ground level to your GPS handset. That's a run of about 12,500 miles. We are seeing continued anomalies there south of the Indian Ocean, Southern Ocean, and Antarctica especially. We also like to show the total electron content for the total electron content anomaly from the 10-day average over North America. So there's that. And no major signals to see there, mostly low electron content anomalies. We also like to show the latest intensitygram and latest solar magnetogram. So let's do that, shall we? There's the refresh. There's the refresh of that. And again, there is a possible new active region rising up here so far. Not a lot to see there. We do have some magnetically complex sunspot groups. This one here is probably the most likely to produce a major flare. It is indeed a beta gamma delta class sunspot group. So for example, this area right here would be what you'd call a delta, as we see a strong umbra there of North Pole orientation just north of that South Pole umbra. So that's significant magnetic shear. That is the sort of thing that allows us to forecast solar flares. We don't really spend too much time worrying about that because, well, there are a lot of things to advance when it comes to understanding of heliophysics, space weather, and indeed cosmology. So let's move on to meteorology, as it's the hottest day in the universe, the hottest day in the history of the universe, 4 days in a row, says ABC News. We'll cover that in a minute. And so since temperature seems to be such an important story, we're showing temperature. So there's Earth's temperatures. The hottest place in the planet, which I guess we got to show this because it's very important. How about Saudi Arabia? It's like pushing 120 in some of those areas there. Also, whatever country that is. Also, North Africa there, seeing some kind of warm temperatures indeed. So that's the hottest part of the planet. For completeness, let's show the coldest part as well. There's negative 91 degrees in negative 92.4 there not too far from the geographic South Pole, at the geographic South Pole, 96.9 degrees below 0 Fahrenheit there. 96.9, nearly 100 degrees below 0. In the Antarctican winter, it is a bit inhospitable down there. Looking kind of cold on the Australian east coast as well. There's the Arctic region, etc., etc. Well, wind is pretty important when it comes to meteorology, so let's cover it. These are the surface winds of the eastern side of the world. These are the jet streams of the eastern world. The jet stream blowing backward there over large parts of the Indian Ocean. Here are the jet streams of the central world. These are the surface winds of Europe, Africa, and the Middle East. These are the surface winds of the Americas. And like sands through the hourglass of time, these are the jet streams of our lives. Earth reaches hottest day ever recorded 4 days in a row. Now, on that note, I won't bring up the Minoan, Viking, Roman, nor medieval warm periods. That would be cherry-picking data or something. However, just keep in mind that they're using the word recorded. The geologic record has recorded some things, like when Antarctica's ice sheets formed about 33 million years ago, the planet was 3 degrees Celsius warmer average than it is today. Also, keep in mind that the northern and southern hemispheres are sort of like almost like separate planets. So that story from ABC News there is a story that I will spend exactly 0 more seconds talking about. Next, our drought intensity map, and good news coming for Wisconsin. Yeah, so currently there's a pretty major drought there in parts of Wisconsin, Iowa, Minnesota especially. However, by Tuesday, that will have subsided quite a bit. So also some significant droughts here continuing in the Pacific Northwest. Anyway, while we're on this, we'll look at moisture anomaly. There's soil moisture anomaly. And there is the raw soil moisture data. So that's good. And sorry for all the alarmists who are saying that food prices are going to rise 10,000%. Droughts going away is good news for people. So sorry about the good news. If it bleeds, it leads. So make sure you unsubscribe from the channel, because we cite facts, whether they're good or bad. Here are clouds and fog over the Americas. So I guess that's neutral. I don't know. I'm not biased about any of it. I'm only interested in good faith in actual facts. That is shortwave radiation showing clouds and fog over the Americas. Here's your weather.gov map. And yeah, we've got some flood watches there, some heat advisories. We'll briefly scroll down to show you the key. There is the key. And the key to being able to forecast your own weather is understanding basic physics. Yeah, basic physics. There's a lot of forces at play, folks. A lot of forces. It's not just gravity. It's not just solar irradiation. It's not just convection. There's a lot of things that figure into it, folks. Saharan dust, for example. All right, so here comes some forecast. This is a 72-hour temperature anomaly forecast in degrees Celsius. Eastern part of the country here mostly anomalously cold. Western part of the country mostly anomalously warm over the next 3 days. Again, it's GFS 72-hour temperature anomaly forecast in degrees Celsius. Here is your GFS 72-hour jet stream forecast, depicting 250 millibar winds, aka the jet stream. It's going to remain pretty coherent here, especially over the northern part of the country, a little bit less so in the southern portion. That may create some funky weather conditions. And of course, the point of most resistance there is going to be around Illinois and then moving across Ohio and indeed Pennsylvania over the next 3 days. Last but not least, here's your GFS 72-hour pressure and precipitation forecast. Some strong storms here moving from Oklahoma down to the Gulf states over the next 3 days, according to the GFS model. And of course, here is total accumulated precipitation. Oklahoma, they're expecting some major rains in the southeast corner, expecting like, let's see, over 4 inches there. That's a 72-hour GFS total accumulated precipitation forecast in inches. And next, your lightning mapper. That's what's been going on the past about 10 hours. Here are the current storms from the time we recorded this video. Keep in mind this was not live stream, but this is where the lightning was. Next time you hear thunder, check out lightningmaps.org. You can convince your friends and foes that you're Zeus or something like that, and that'll be fun. Maybe you could pretend to be a horror movie character or something like that. As we pause for station identification, welcome to the Smash News Network, Least Busted Name in News. Did you know that in 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit? We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. No, you certainly can. We even created our own financials so that we're just forging our own path here. That's why we built our own websites and told certain social media organizations that they can blank our blank all blanking day, and in the meantime they can go blank themselves. Here's where we'll close out today's space weather and earth weather together video with the lower 48 Doppler. Clouds and fog over the lower 48. And let's don't forget water vapor. So here's your recap. And hopefully you're not consuming a bunch of real crap on YouTube. There's certainly a lot of it. And we follow a lot of channels that produce crap because we have to do market research based on what our viewers are also watching. It's shocking. It's shocking how dumb and phony certain six-figure subscriber YouTube channels indeed are. There's clouds and fog once again. It's still dark over half the country, so clouds and fog is great to view in 3.9 micrometer infrared radiation, part of the NASA GOES interactive weather satellite suite, like the water vapor map. And there is that. That should clear up your Doppler if you are confused about what will happen next. Anyway, thanks for tuning into the Smash News Network. Please bust the name of news. All of this scary, spooky weather and all these high temperatures and all of these other frightening things that have been going on. I mean, stars, galaxy, temperature. It's way too spooky for me to be able to deal with. So while I'm in the bunker, may that solar wind be at your back. Going back to the bunker again. All the stupid crap I've heard has encouraged me to jump in. Whoa.